On December 4th, the ThreeI Atlast transmitted a 14 to 20 MHz signal that caused an explosion on Jupiter. When the layers of data were decoded, people in turn discovered a sequence of prime numbers, a map of the Milky Way, a curved spacetime grid, the signature of a gamma-ray burst tied to the hypothesis of a collapsing multiverse boundary, along with a map of a safe corridor, transforming ThreeI Atlast from an anonymous wanderer into a cosmic black box and a migration compass of a lost civilization. After that, Atlast and Swan seemed to trigger symmetrical explosions on Jupiter, bending their orbits to gradually slide into Earth's orbital lane, forcing humanity to use radiation pressure and a distant nuclear pulse to correct their trajectory, before Atlast quietly departed, leaving behind a trove of mysterious data and an unanswered question: is the universe merely warning us, or is it waiting for our reply? What terrifying thing is silently unfolding behind ThreeI Atlast's successive actions? We will follow each trace together right now. In the raw stream, every sample from ThreeI Atlast fell exactly where the equation said it should never one bin off. Noise that usually blurred cosmic radio into a soft haze fell away from the trace tied to ThreeI Atlast like water running off polished glass. No scintillation, no drift, no wandering sidebands appeared even as the planet turned and receivers switched. The tone linked to ThreeI Atlast remained surgically locked to 1420, 4.75 MHz. Models that usually tame wild data offered nothing useful this time. Every attempt to explain the signal from ThreeI Atlast as flare lightning mesa or machinery echo collapsed under its own approximations. The algorithm simply circled back to the same conclusion. If the statistics were right, the transmission from ThreeI Atlast carried more order than any known astrophysical source. That verdict tightened something in every room watching the feed. The question stopped being whether ThreeI Atlast was interesting, and became whether the message implied by such precision was survivable to ignore. In hushed exchanges, analysts agreed on a single priority that pushed aside everything else connected to ThreeI Atlast. The data block on the hydrogen line had to be opened layer by layer until whatever waited inside finally admitted why it had chosen to speak with such impossible clarity. The night was quiet enough that the instruments could almost be mistaken for a distant mechanical lullaby. The radio array listened across the sky toward the sector where tracking software followed a dim object named ThreeI Atlast, sifting through soft static until one narrow tone rose above the haze of background noise. That tone lay exactly on the hydrogen line, a frequency chosen by physics rather than by any culture steady and clean. The direction of arrival pointed back to a faint, fast-moving object the tracking software called ThreeI Atlast, an interstellar guest on a sweeping hyperbolic course. ThreeI Atlast had already drawn attention for a small but persistent excess acceleration, a motion slightly out of step with simple gravitational prediction. Now the same coordinates produced a signal that refused to smear or wander, as though some unseen hand kept the transmission perfectly tuned. The pattern did not resemble lightning flares, or the usual murmurs of magnetized plasma that observers had catalogued from past campaigns. Instead, the spike rose held and faded with almost metronomic discipline, inviting the possibility that ThreeI Atlast carried more than frozen rock and metal. The team logged the time, the amplitude, and the subtle structure in the noise floor surrounding the hydrogen line, building a careful record. One after another, environmental checks returned clean, ruling out local interference, and leaving the Sky ThreeI Atlast and the hydrogen frequency as the remaining trio. Every additional verification hardened the impression that a deliberate process had shaped the pulse, even if no one yet agreed on what that process might be. In quiet conversations over coffee and glowing screens, some researchers began to frame ThreeI Atlast not as a passive visitor, but as a possible device. Others reminded the group that nature frequently discovers ways to surprise, and that unknown plasma dynamics could still imitate design at great distance. Between those two positions, the working hypothesis slowly took shape, balancing caution with curiosity and centering on ThreeI Atlast as the critical point of reference. That emerging hypothesis would guide the next step when the team turned from simply detecting a pulse to wondering whether a message might be hidden inside the numbers. When the team slowed the recorded pulse and stretched it across their screens, a hidden structure sharpened. The narrow line at the hydrogen frequency from ThreeI Atlast resolved into a train of digital steps evenly spaced in time. Those steps, when grouped, formed clusters that appeared only in counts of 2, 3, 5, 7, and 11. The pattern refused to break into tidy blocks of 4 or 6, as though something were avoiding composite numbers with care. Prime numbers had long been proposed as a universal signature of reasoning minds, and ThreeI Atlast now seemed to be counting. The researchers converted the on and off states into ones and zeros, letting the binary stream fall into a long ribbon. Once arranged, the ribbon of data from ThreeI Atlast curved and folded into a rectangle, whose proportions were themselves prime. Within that rectangle, certain points brightened while others stayed dark, assembling a coarse but unmistakable image. At first glance, the image resembled a disk seen from above, bright at the centre and thinning toward the edge. A small mark near one of the tapered arms indicated a location away from the bright core, suggestive and precise. When overlaid on existing models, the layout matched the general outline of the Milky Way, with ThreeI Atlast tagged in one spiral arm. The coincidence pressed beyond comfort, because random noise rarely paints a galaxy and labels the current visitor in the same stroke. No one in the room argued that the map was high resolution, yet the intention behind it felt unmistakable. ThreeI Atlast appeared to be saying in the simplest visual language available, where the sender once stood within the larger structure. That recognition produced a quiet shift in mood, replacing abstract curiosity with a sense of reading something personal and distant. The first layer had been peeled back, and attention began to turn toward what deeper patterns ThreeI Atlast might have buried underneath the map. The choice of the hydrogen frequency did not feel accidental once the map from ThreeI Atlast emerged. The hydrogen line had always been a quiet meeting place in theory, a place where any culture with radio astronomy could reasonably be expected to listen, and ThreeI Atlast had now used that meeting place with unnerving precision. Unlike frequencies shaped by technology or atmosphere, the hydrogen line was set by the structure of atoms themselves, and that made the decision by ThreeI Atlast feel almost ceremonial. Across the control room, researchers found themselves repeating the same thought in different words that ThreeI Atlast had selected the most neutral stage the universe could offer. Another question rose beside that choice of frequency, centered on the moving carrier that ThreeI Atlast provided. The signal seemed tied not to a fixed beacon in deep space, but to a visitor sweeping in and then out again, so that every repetition came from a slightly different point in the sky, where ThreeI Atlast had advanced along the hyperbolic track. The design hinted that the message might be meant to travel with ThreeI Atlast drifting through many systems, rather than shining from a single star. In that reading, ThreeI Atlast resembled a slow bottle thrown into a galactic ocean, rattling softly with a sealed letter inside. The character of the transmission changed after the prime number map, and that shift focused attention once more on ThreeI Atlast. A final shorter burst rode on the hydrogen line, denser in structure with fewer obvious pauses, as though ThreeI Atlast had poured the remaining content into one last compressed block. Simple rearrangements no longer produced clean images or familiar sequences, and every new attempt to unfold the data from ThreeI Atlast ended in tangled patterns that refused easy interpretation. Spectral analysis still revealed regularities, yet those regularities seemed to belong to some higher grammar that the tools around ThreeI Atlast were not yet prepared to read. In discussion, a working idea settled over the group, framing this last block as a kind of locked compartment entrusted to ThreeI Atlast. The earlier layers felt like a greeting and a map, while the compressed tale suggested something more guarded, perhaps a conclusion the senders would only entrust to minds able to unlock the structure that ThreeI Atlast carried. That possibility wrapped the room in a quiet, almost reverent mood, turning curiosity toward patience, and toward the deeper layers that might still be waiting behind the next transformation of data from ThreeI Atlast. The second wave of data arrived without warning, announced only by a sudden sharpening of the hydrogen line that carried Atlast. On the monitors, the steady tone from ThreeI Atlast grew cleaner, as if someone had quietly adjusted the focus of a lens. Sampling at higher resolution revealed that the flux from Atlast no longer behaved like simple pulses, but like threads weaving across a hidden grid. When the team rebinned the stream, the bits from ThreeI Atlast began to fall into a repeating lattice of squares and rectangles. Within that lattice, Atlast arranged bright and dark cells into curves that bowed and dipped, refusing straight lines. The resulting pattern resembled a sheet of fabric pressed down by invisible weights, the way mass bends spacetime in standard diagrams. Overlaying theoretical curvature plots on the pattern from ThreeI Atlast produced an uncomfortable alignment. Regions where Atlast brightened matched the expected wells of heavy objects, while lighter zones appeared where gravity should be weak. In effect, Atlast seemed to be sketching a relief map of spacetime itself, rather than drawing stars or planets directly. The more they compared, the clearer it became that Atlast was not marking positions by coordinates alone. Instead, ThreeI Atlast referenced the gradients of gravitational potential, as though anyone reading the message could navigate by how steep or shallow the local fabric felt. Such a method would work in any galaxy, provided the reader understood how mass sculpts geometry, and that universality deepened the silence in the room around Atlast. A quiet realization followed, spreading from screen to screen, as analyses converged on the same conclusion about ThreeI Atlast. The message did not appear to be addressed specifically to humanity, but to any intelligence capable of measuring curvature and decoding the map Atlast had drawn. Rather than pointing at Earth 3, Atlast had embedded information in the one structure that every observer shares: the geometry of the universe. That understanding brought a subtle emotional shift, a sense that Atlast was less a visitor speaking to one world and more a courier passing through, leaving instructions in the shape of gravity itself. With that layer, decoded attention turned back to the compressed block at the end of the transmission from ThreeI Atlast, and to what kind of event might have required such a precise and universal warning. As the reconstructed lattice from the second layer extended farther across the virtual canvas, one region pulled the eye. In that sector of the pattern, the gentle curves that ThreeI Atlast had traced began to steepen and intersect. Lines of gravitational gradient drawn by Atlast, which elsewhere flowed smoothly around wells and ridges, here converged into a tightly knotted focus. Cross-checking the coordinates showed that this focus from Atlast did not correspond to any familiar bright cluster or major galaxy. Instead, models placed the convergence where surveys hinted at the remnants of a small devoured dwarf galaxy, a place where stellar orbits no longer followed simple paths. The gravitational record in that zone, once folded into the map that Atlast had supplied, resembled a scar rather than a simple depression. When the team followed the path of increasing distortion that Atlast had outlined, the trail led beyond the scar and into a region of modelled instability. There, at the terminus of the route traced by ThreeI Atlast, the lattice did something new. Bright cells arranged by Atlast formed a repeating motif, a symbol-like cluster paired with a finite countdown digit stepping down instead of primes stepping up. The juxtaposition felt deliberate, and once seen, no one in the room could unsee the intention that Atlast seemed to imply. The earlier map of primes and curvature now looked less like a neutral survey, and more like the recorded approach to a boundary with Atlast marking both the wound and the warning. In quiet discussion, the working hypothesis took shape that ThreeI Atlast was carrying the functional equivalent of a black box, a compressed testimony from a civilization that had passed through that boundary and failed to emerge whole. The idea changed the tone of the investigation, adding a subdued weight to every new comparison with the map that Atlast had provided. Data no longer felt abstract when framed as the last careful record of a catastrophe that ThreeI Atlast had been tasked to preserve. From that point forward, analysis focused less on whether a message existed, and more on what kind of cosmic event could have compelled minds to entrust their final account to Atlast. The third layer emerged when the team stopped treating the residuals as noise and began to read them as a timeline. In the cleaned data, ThreeI Atlast no longer drew static maps or fixed lattices, but a changing pulse that rose and fell across energy bands. Where earlier layers from ThreeI Atlast had spoken in primes and curvature, this layer unfolded as a light curve written in radio form. Spectral reconstruction showed a brief, ferociously bright spike, encoded by Atlast, followed by a long, fading tail spread across multiple channels. The profile mirrored the familiar shape of a gamma ray burst, the kind that empties energy in seconds that stars release over lifetimes. Yet the parameters that ThreeI Atlast encoded, the duration and hardness and afterglow, refused to match any entry in human catalogues. The direction implied by the timing corrections pointed straight back through the scarred region that Atlast had highlighted in the gravitational map. Taken together, the evidence suggested that ThreeI Atlast was replaying the signature of a real event, not a hypothetical model. The pulse that Atlast preserved appeared to be the recorded burn of a catastrophe that had once torn through the dwarf galaxy remnant. Each detail that matched theoretical expectations made the discrepancies at the margins feel more like eyewitness flourishes than computational artifacts from Atlast. A quiet understanding settled over the room as the third layer clicked into place around ThreeI Atlast. The message no longer resembled a neutral atlas, but the logbook of a storm that had already passed through someone else's sky. In that framing, ThreeI Atlast became less an abstract courier and more a memory device entrusted with holding the trace of a specific disaster. That shift in perspective prepared the team to look at the remaining equations, from Atlast not as isolated curiosities but as the second half of a narrative about where such storms come from and how they move. When the encoded light curve was laid over the gravitational lattice, a new pattern took shape. The team used the warped grid that ThreeI Atlast had drawn as a coordinate frame and traced the implied direction of travel for the recorded storm. The reconstructed trajectory began in the devoured dwarf galaxy, skimmed through the scarred region of twisted orbits, and then continued outward along a shallow spiral. In the model, the wavefront marched slowly but inexorably through space, following the same gradient lines that ThreeI Atlast had emphasized. Extrapolated forward, the path intersected the spiral arm where the sun resides not in years or centuries, but across sweeping galactic timescales. Alongside this trajectory, the team found a separate cluster of symbols embedded in the data from ThreeI Atlast. These symbols combined familiar constants with operators not typically used in standard cosmology, arranging themselves into relations that resisted simple reduction. When translated into human notation, the expressions resembled equations for a boundary surface whose stability could suddenly fail, as though ThreeI Atlast were describing a membrane between domains of spacetime. The resemblance to speculative multiverse boundary models was too close to dismiss as coincidence. Researchers who had worked for years on purely theoretical papers now saw echoes of their own diagrams in the formulations that ThreeI Atlast appeared to endorse. The idea emerged that the catastrophe ThreeI Atlast had logged might not be just a stellar collapse, but the local consequence of a larger structural failure in the fabric between regions of reality. That hypothesis did not yet prove anything, but it altered the emotional tone in the control room around ThreeI Atlast. The message felt less like a random record and more like a diagnosis of a recurring condition, with the mapped trajectory suggesting where the next episode could unfold. With that framing attention turned toward the remaining layer of data from ThreeI Atlast, searching for any hint that someone had once tried to describe how to survive such a passage. The fourth discernible pattern emerged when the team paired the storm signature with another half-hidden structure that ThreeI Atlast had tucked into the data. Where the gamma curve had described what happened, the new layer from Atlast seemed to describe where to go next. Vector arrows encoded as sequences of directional shifts appeared superimposed on the curvature grid that ThreeI Atlast had already drawn. Each arrow from Atlast pointed away from the scarred region and toward a narrow corridor that threaded through gentler gradients of spacetime. When mapped into galactic coordinates, the corridor traced by ThreeI Atlast skirted dense clusters and regions rich in dark matter, favouring a path along a quieter arc of the disk. At the terminus of those arrows, the models revealed a strangely calm zone. Density maps showed that the region highlighted by ThreeI Atlast lay in a trough of unusually low, dark matter concentration, a gravitational hollow where tidal forces relaxed. The anomaly fit no simple expectation from large-scale structure simulations, but the stability indicators that Atlast encoded there were consistently high. To the analysts, the implication was unsettling and comforting at once. ThreeI Atlast appeared to be marking not only the site of destruction, but the outline of a refuge, a galactic buffer where the influence of boundary failures might be weakest. The idea that a lost civilization had once charted such a sanctuary, then wrapped the directions into Atlast lent a quiet poignancy to the diagrams. In whispered discussions, the team began to see ThreeI Atlast less as a neutral warning buoy and more as a guidepost for migration at cosmic scales. If the reading was correct, the message from ThreeI Atlast contained the memory of a path taken, or at least planned a route toward a gentler corner of the Milky Way. That realization led naturally to a more difficult question, as researchers considered how any society, including the one decoding Atlast, now might decide whether to share such a map or keep the knowledge tightly held. The question of what to do with the map and the storm record arrived almost as forcefully as the data from ThreeI Atlast itself. Around dim conference tables, the team weighed whether releasing every detail from Atlast would inform a distant future or simply frighten the present. Some argued that any society capable of decoding ThreeI Atlast deserved unfiltered truth, including the projected path of the boundary failure and the refuge corridor. Others warned that a countdown traced by Atlast, even on galactic timescales, might be twisted into fuel for fear or fatalism long before it was useful. While the debate unfolded, ThreeI Atlast continued to recede along its hyperbolic path, its signals slowly weakening as distance grew. Monitoring stations tracked Atlast as long as they could, watching the hydrogen line from Atlast flicker closer to the noise floor. Then, as if in answer to a question the room had not yet put into words, Atlas brightened briefly one last time. The final pulse carried no obvious primes, no maps, no arrows, only a tightly compacted cluster of symbols encoded by ThreeI Atlast. When translated, the cluster from Atlast unfolded into a single elegant equation, referencing the same operators that had appeared in the boundary models. Side-by-side comparisons showed that the formulation from ThreeI Atlast matched almost term for term a speculative multiverse boundary equation developed by a small group of terrestrial theorists. The convergence left little room to dismiss the message from Atlast as coincidence or pattern-seeking. 3. Atlast now seemed to be affirming that the catastrophe it recorded was tied to the failure of the same kind of boundary humans had only imagined on paper. That recognition softened the arguments in the room, shifting the discussion from whether to acknowledge a threat toward how to frame ThreeI Atlast as both warning and invitation. With the last signal from Atlast already fading into the background, the team turned to the remaining layer of the message, searching for any guidance on what to build next. Once the boundary equation aligned with terrestrial theory, the meaning of the transmission from ThreeI Atlast settled into a new clarity. The pieces that Atlast had offered, from prime numbers to curvature maps and storm signatures, now read like chapters in a single account. In that account, ThreeI Atlast carried the memory of a civilization that had watched a boundary fail, survived long enough to understand it, and then disappeared. Archival estimates suggested that the senders had lived and died millions of years before any human instrument first noticed Atlast. That distance in time turned the signal from ThreeI Atlast into something more like a fossil than a live conversation, a record pressed into radio. Yet the inclusion of a refuge corridor and a stable zone meant Atlast was not only describing extinction, but the outline of a possible escape. Researchers began to speak of ThreeI Atlast as a kind of cosmic black box designed not to prevent a crash but to explain one. At the same time, Atlast looked increasingly like a compass, its arrows and equations pointing toward conditions under which such storms might be gentler. The dual role did not erase the sadness implied by the loss encoded in Atlast, but it added a muted note of gratitude. Quietly, planning groups drafted the first concepts for an Atlas follow-up program, taking Atlast as both warning label and design specification. Rather than imagining an immediate evacuation, they framed the message from ThreeI Atlast as instructions for instrument surveys and slow technologies that future generations might need. In that framing, the legacy entrusted to Atlast was not a demand for panic, but an invitation to think on galactic timescales. With that invitation in mind, attention turned outward again toward the broader system that ThreeI Atlast was leaving behind, and to the strange reactive behaviour beginning to appear around Jupiter. The first reports from Jupiter came in as brief alerts, quiet flags buried in routine monitoring logs. Automated systems had noticed that a patch of cloud tops on the giant planet brightened and dimmed in a pattern too clean for ordinary weather. At the time, ThreeI Atlast was already far past the orbit of Mars, and only a few people still watched the trajectory plots where Atlast traced a pale curve. Initial assumptions looked simple enough. The brightening on Jupiter was logged as a likely impact, another small object swallowed by the deep atmosphere while Atlast continued onward. Follow-up analysis, however, showed no incoming debris trail to match the supposed strike, and Atlast appeared nowhere near the line of sight. A second brightening occurred on the opposite limb of the planet a short time later, this time with the same peak intensity and duration. Side-by-side overlays revealed that the two flashes were nearly mirror images, forming a pair of luminous scars across the Jovian bands. The coincidence pushed investigators to pull older data, and once again the name of ThreeI Atlast appeared in the query tied to the time window. Reconstructed ephemerides demonstrated that ThreeI Atlast and the companion object Swan had brushed past Jupiter's magnetosphere just before the first flash. The path traced by Atlast skimmed a narrow slice of the planet's gravitational well, while Swan's trajectory threaded a similar lane only minutes apart. Computer models confirmed that both Atlast and Swan had passed through regions where magnetic field lines were tightly coiled like springs under tension. When the positions were plotted together, the flashes on Jupiter fell exactly along the projected interaction zones of Atlast and Swan. The geometry suggested that the planet had not simply been struck, but had responded as though something within the visitors had triggered a symmetric reaction. Quietly, teams began to reclassify the events, no longer speaking of random impacts, but of paired detonations synchronized with the flyby of ThreeI Atlast. The realization that Jupiter's outbursts aligned so precisely with the passage of Atlast and Swan changed the questions on everyone's screens. From that point, the investigation shifted toward understanding what kind of internal mechanism could make Atlast and Swan provoke such balanced explosions, and whether the same mechanism might respond in similar ways elsewhere along their evolving paths. The energy curves from Jupiter refused to behave like simple flares once they were stacked and aligned. Every time analysts overlaid the light profiles with the predicted magnetospheric crossings of ThreeI Atlast, and Swan's subtle ripples reappeared in the same positions. Those ripples formed secondary peaks riding on the main flash like echoes inside a bell, and each echo kept pace with the projected motion of ThreeI Atlast. Fourier transforms pulled out a set of discrete frequencies, repeating within the plasma glow a harmonic ladder rather than a smooth spectrum. The spacing of those harmonics matched to surprising precision the modulation bands that ThreeI Atlast had used earlier around the hydrogen line. It was as if the Jovian atmosphere had been driven to sing using the same notes that ThreeI Atlast once used to draw maps. This coincidence pushed the team to consider that Jupiter was not only reacting to mass or momentum, but to the tuning of fields carried by Atlast. In that picture, ThreeI Atlast and Swan acted as keyed resonators releasing stored energy when they crossed field strengths that matched their internal settings. The planet became a giant amplifier converting whatever pattern Atlast carried into visible symmetric bursts. The idea that a world could be made to answer a passing visitor in harmonics altered the mood in the control room around ThreeI Atlast. Speculation turned toward what might happen when Atlast and Swan crossed other regions where field geometry aligned with their hidden frequencies. With that in mind, attention shifted from Jupiter's completed duet to the changing orbits of ThreeI Atlast and its companions searching for the next place where such a trigger could be pulled. Laboratory work on the incoming datasets soon turned toward the physical nature of the visitors themselves. Mass estimates derived from trajectory changes showed that ThreeI Atlast behaved as if it were far denser than a typical comet. The same tracking indicated that swarms of dust did not trail ThreeI Atlast in the expected way, leaving its silhouette unusually clean. Spectral analysis of the companion object revealed a different peculiarity. Reflected light from Swan carried absorption features that did not match common ices in the outer system. Under modelled conditions, the closest match behaved like an exotic solid that destabilized violently when squeezed by strong magnetic fields, a kind of reactive ice. ThreeI Atlast, by contrast, reflected light in a pattern, closer to alloyed metal than to frozen gas. Radar profiles, where available, suggested that Atlast returned echoes with sharp transitions, as though its interior contained boundaries more abrupt than random rock. In simulation, a body like ThreeI Atlast would house cavities and denser cores, stacked together more reminiscent of engineered compartments than of a single fused block. The combined picture made Swan look like a carrier of volatile material and ThreeI Atlast like a structured shell wrapped around a responsive heart. If the harmonics at Jupiter had been a song, Swan seemed to have provided the fuel, while Atlast supplied the tuned instruments. That interpretation did not prove intention, but it nudged discussions toward the language of systems and components whenever researchers spoke about ThreeI Atlast. Quiet unease mixed with fascination, as teams realized that mass composition and reaction all aligned with a device-like reading of Atlast and its companion. With those traits in mind, attention moved on to the choreography of their paths, and to the way ThreeI Atlast and Swan had threaded the delicate balance points around Jupiter with uncanny precision. When the trajectories were plotted in detail, a new pattern emerged that unsettled even cautious analysts. ThreeI Atlast and Swan did not simply fall past Jupiter. Both arrivals brushed the same narrow corridor around the planet. The times of closest passage for ThreeI Atlast and Swan differed by minutes, yet the entry angles matched within razor-thin tolerances. Gravitational simulations showed that random scattering would almost never drive two unrelated objects through such aligned gateways. The preferred pathways that ThreeI Atlast followed threaded directly through Lagrange regions where Jupiter and the Sun balance one another. Those balance points act like saddles in spacetime, and ThreeI Atlast seemed to step onto each saddle deliberately rather than drift across. When small perturbations were added to the models, ThreeI Atlast either missed the detonations entirely or struck Jupiter head-on. Only a narrow band of starting conditions reproduced the graceful skims and symmetric flashes that actually occurred near ThreeI Atlast. That sensitivity led teams to speak of guidance, as though ThreeI Atlast had internal instructions for navigating field lines and wells. Swan fit naturally into the same language, behaving like a secondary component slave to the corridor that ThreeI Atlast selected. The idea of programming wrapped itself around every new discussion not as proof of authorship, but as a working descriptor for ThreeI Atlast. With controlled passage now a central assumption, attention shifted toward the inner system, where the bent orbits of ThreeI Atlast and Swan were beginning to intersect the highway of the Earth's own path. Trajectory models grew more complex as new measurements arrived, and each refinement narrowed the margin around Earth. Simulations that began with the post-Jupiter paths showed ThreeI Atlast and Swan bending inward their shared corridor, slipping from the realm of distant interest into the plane of familiar orbits. When long integrations were run, the line traced by 3, Atlast crossed the broad annulus, where Earth travels not as a direct collision, but as a grazing intersection. In most runs, the miss distance for ThreeI Atlast remained comfortably large, yet close enough that magnetospheric coupling and wake effects could not be dismissed. The more troubling outcomes centered on Swan, whose modelled fragmentation under strong fields produced clouds of energized particles sweeping ahead of and behind ThreeI Atlast. Under those conditions, the companion plume behaved less like a spray of debris and more like a travelling plasma storm. The storm front, still keyed to the harmonics first seen at Jupiter, could in principle induce currents in planetary fields even without a physical strike from ThreeI Atlast. On Earth, such forced coupling raised the prospect of extreme space weather saturating radiation belts and flooding technological systems, while ThreeI Atlast passed at a seemingly safe distance. Analysts describe the scenario cautiously framing the danger not as inevitable impact, but as an electromagnetic tempest riding in the same lane as ThreeI Atlast. In that language, ThreeI Atlast became the organizer of conditions, rather than the direct weapon, the conductor that told Swan's reactive material when and where to release energy. With those projections in hand, discussion began to pivot from pure diagnosis toward intervention, asking what, if anything, might gently reshape the corridor that ThreeI Atlast was beginning to carve through the inner system. The projections forced a change in vocabulary, and the control rooms began to speak of devices rather than visitors. ThreeI Atlast and Swan no longer fit comfortably inside the language of random comets, because every new datum reinforced the sense of tuned response. In reports drafted overnight, ThreeI Atlast appeared alongside phrases like reactive payload and triggered emission, as if Atlast had been designed to awaken only under certain fields. That shift in framing made the usual catalogue of planetary defences feel suddenly clumsy. Standard playbooks spoke of kinetic impactors and explosive charges, tools meant to shove or shatter rocks, not to caress something wired for resonance like ThreeI Atlast. Engineers warned that a direct strike on Swan, or a violent detonation near ThreeI Atlast, could drive the internal materials into the same unstable regimes that Jupiter had briefly exposed. The worst-case sketches did not show craters, but halo shells of driven plasma spreading ahead of ThreeI Atlast and back along the shared corridor. In those sketches, ThreeI Atlast served as the organising centre of a storm that human actions had inadvertently amplified. No one wanted to be remembered as the generation that turned a difficult alignment into a manufactured disaster by mishandling ThreeI Atlast. As meetings lengthened, two constraints hardened around every option. Any intervention had to keep a respectful distance from the reactive ice that Swan carried, and any push on ThreeI Atlast had to remain gentle enough to avoid ringing the internal harmonics. Within that narrow space, ThreeI Atlast still offered a target for influence, but the tools would need to look more like adjustments than blows. Teams began to sort proposals into families marking which ideas merely changed the lighting around ThreeI Atlast, and which genuinely nudged the path. Under the muted glow of shared screens, the conversation turned toward fields radiation pressure and distant shocks, and toward ways to persuade ThreeI Atlast and Swan to choose a slightly different lane without ever hearing a shout. The gentlest proposal on the table began not with explosions but with light. Physicists reminded the room that photons carry momentum, and that a steady stream of reflected sunlight could over time lean on ThreeI Atlast, without ever touching its reactive insides. In that picture, fleets of small craft would unfurl mirrors or sails along the corridor and focus a slightly brighter beam toward the metallic skin of ThreeI Atlast. Simulations showed that even a tiny change in pressure applied for weeks or months could accumulate into a measurable bend in the path of ThreeI Atlast. Because the push came in the same language that stars already spoke, the intervention looked less like an attack and more like a subtle redirection of wind. Engineers liked that the method never needed to approach Swan closely, leaving the volatile ice to drift where ThreeI Atlast no longer planned to go. Alongside that soft strategy sat a harder, more controversial option. Some argued that a carefully timed nuclear standoff burst detonated far from ThreeI Atlast, and Swan could sculpt the plasma along the corridor. In that scenario, a remote explosion would send a pressure wave through the thin interplanetary medium, nudging the reactive cloud and the guiding mass of ThreeI Atlast away from the Earth-crossing lane. Models supported the physics in principle, but the margin for error around ThreeI Atlast was thin. Too much energy in the wrong geometry could accidentally ring the very harmonics that Jupiter had echoed back, turning a controlled shove into a choir of unwanted flares. Debates over this option often circled back to the same unease, the fear that ThreeI Atlast might answer a rough gesture with a complicated global reply. Still, planners could not dismiss the standoff burst entirely, because radiation pressure alone might not be enough if ThreeI Atlast strayed too close. In the end, drafts of the defense architecture paired both ideas favouring reflected light as the primary touch, while keeping the distant shock as a last resort. With that tentative balance in place, attention turned from tools to timing, and to the question of how to speak first in a language of fields that ThreeI Atlast seemed to understand all too well. The decision window tightened just as the signal pattern began to change again. Monitors that had once shown isolated flashes from Jupiter now displayed a quieter but more intricate rhythm, and ThreeI Atlast sat at the centre of every discussion. When analysts reprocessed the Jovian data using the new orbital elements, a fresh regularity surfaced. The intervals between secondary peaks shifted subtly as ThreeI Atlast and Swan moved deeper into the inner system, as if the harmonics were being retuned in real time. What had first looked like static echoes of a past event now resembled a sequence stepping through a series of preferred frequencies anchored to the path of ThreeI Atlast. Plotted against distance and local field strength, the pattern from ThreeI Atlast lined up along smooth curves instead of random scatter. Each new adjustment in the waveforms matched the changing magnetic environment that ThreeI Atlast encountered on its inward arc. To several teams, the behaviour looked like calibration, as though ThreeI Atlast were using Jupiter's response as a reference to synchronise an internal clock. The hypothesis grew that ThreeI Atlast might be aligning its internal oscillators to the specific mixture of solar wind and planetary fields found in this part of the system. Under that reading, the evolving harmonics were less a message to observers and more a handshake protocol between ThreeI Atlast and the local environment. Once that handshake completed, whatever process ThreeI Atlast had been wired to perform could in principle begin without further prompting. This idea added a new emotional weight to timelines on the wall. Every plotted tick mark became not just a date of closest approach, but a potential milestone in the synchronization sequence of ThreeI Atlast. Rather than simply racing a physical arrival, planners now felt they were racing a calibration curve, hoping to nudge ThreeI Atlast onto a different track before the pattern reached its natural end. The first tests arrived as almost imperceptible shifts in the tracking numbers small enough to hide in rounding, until someone looked twice. Arrays watching ThreeI Atlast reported a tiny steady drift away from the original corridor, exactly in the direction that the concentrated sunlight had been pushing. Frame by frame, the reflected glint from ThreeI Atlast brightened and faded, with the cycling of the sail fleet confirming that the beams were landing where planners had aimed. Over days, the arc of ThreeI Atlast bent a fraction of a degree, not enough for drama on a sky map, but enough to move the future crossing clear of the most crowded part of Earth's lane. Through all of this, the harmonic structure around ThreeI Atlast stayed smooth, showing no sudden jumps, no new spikes that would have hinted at agitation. Swan behaved more nervously. Models predicted that the reactive ice would amplify any clumsy touch, so controllers reserved the nuclear standoff option for a single carefully chosen moment. When the distant burst finally came, the shock front brushed the region where Swan's projected plume had thickened, and monitors watched for any sign that ThreeI Atlast had joined the response. Instead, sensors recorded a brief shimmer in Swan's wake and a gentle reduction in its spin, just enough to bleed energy out of the developing storm band behind ThreeI Atlast. The corridor shifted outward, and the densest part of the modelled plasma sheet peeled away from the Earth crossing. ThreeI Atlast continued on the new line carved by light quiet and composed, while Swan's signature slowly thinned. The contrast left teams cautiously hopeful, as if they had managed to whisper directions to ThreeI Atlast and Swan without raising their voices. Long after the danger had eased, the harmonics continued to rearrange themselves in the data around ThreeI Atlast. What remained was a quieter, clearer motif, as if Atlast had condensed its role into one final signature. To many on the Project 3, Atlast now looked less like a threat, and more like a messenger completing a long-assigned arc. The equations and maps that Atlast had carried became part of human archives folded into new plans and far future designs.